Uh, Adikesha, put a message to in the group, unofficial group. Let them they
Okay,
can
sir.
join immediately.
Okay, sir.
It's too late now. Let's start. Yeah, let's start now because it's already 10 minutes late. Okay. So in the last class, we discussed about the physical properties of minerals. What are those physical properties? Color, luster, and chemical composition, specific gravity, and streak. Okay. The screen is sharing now. Okay. Yeah. Can you see the screen now?
Yes, sir.
Yeah. Okay, right. So in the last class, we discussed all these properties. So color, form, streak, luster, cleavage, fracture, the affinity, hardness, specific gravity, and chemical composition and occurrence, and industrial and economic uses of the mineral, specific mineral. Okay, and if there are any special character like magnetic attraction, or maybe some minerals like a calcite, they used to react with the HCl, hydrochloric acid. Okay, these are the main physical properties of minerals, and in the exam you may ask to elaborate or briefly describe what is a affinity, what is a fracture, or we may ask for the what is the economic uses of this particular mineral. Okay, those things we may ask for to briefly describe. Okay, let's start with the first mineral called the quartz group of minerals. So here there are varieties of quartz you might have seen, but you may not identify exactly it is silica or whatever the things. Okay, so in the rock, varieties of quartz, so here you can see the rock crystals. It's a colorless, it's a quartz. Okay, completely transparent, color is white. Okay, and so here is the rosy quartz. It's a type of quartz. Okay, and because of it's a rose color, we call it a rosy quartz. It's a translucent, that means it's a partially transferring the light, not 100%. Okay, and milky quartz, it's it's a milky white, and generally almost all the quartz group of minerals we use for the manufacturing of glass industries, and even for the some typical equipment called ultrasonic, and even for radio frequency also we use this. Okay, and in most of the place, what you call in insufficient if the composition are there, say for example in a what you call cement manufacturing industries, if there is any less quantity, less percentage of silica percentage, if it is there, they used to add the silica, that means as a like sand. Okay, that is rich of silica percentage. The next one is the gray quartz. It's a gray color. It's a translucent amethyst. It's a type of the varieties of the amethyst you can see there. And smoky quartz, it's a dull luster. Yesterday I showed that. I will show you once again that. And so some green quartz. Okay, those things are, and there are some many more. The chalcedony, agate, jasper. These are all associated with some other metals. Okay, I'll show you so one by one. Chalcedony, agate, jasper, chert, and amorphous opal. These are all the different varieties of quartzes. Okay, right. So let me show you some of the pictures. Yeah, here you can see in the majorly, you can see that what is a quartz. The first property of the mineral is color. What is the color here? It's a rose color, rosy quartz. It's a completely what we call this white color. We call it as a milky quartz, and this is a smoky quartz. It's a smoke color. That's why we call it as a smoky color. Okay, and here these are all the varieties of quartz. So the next properties are here. When you go back to the these slides, streak. Generally, it will be a white streak, and form it will be a give me a minute. Let me show things there. Okay, right. It is generally the quartz. It's the streak is white, luster is vitreous always, and vitreous luster, and cleavage is will be there, and fracture is even fracture, and some are uneven fractures, and the affinity will be there. Some are transparent, some are translucent. Okay, and hardness is 7. As I told you in the hardness scale, most scale of hardness, the quartz group of minerals all are giving the 7 hardness. And specific gravity is a medium, and this chemical composition will be SiO2, silicon percentage. and occurs in almost all the rock types, igneous rocks, sediment rocks, and even in metamorphic rocks. In all types of rocks, you can see this quartz. Okay. Industrial and economic uses, as I told, this is useful for manufacturing of glasses and some typical what you call this instruments. Okay, and magnetic attraction, no need, and diluted silicate, it's not going to happen, right? And I'd like to show you some of the charts how you are going to write this. What you call this? Yeah. Yes, see here, generally you need to write the exam in the exam point of view, how you are going to write this, and here we are not showing this, but any group, you can take this, like this. These are the properties. If you ask, what is, write down the physical properties of Smoky Quartz or Milky Quartz, or it may be the Rosy Quartz with the industrial uses. So you need to write first the properties like this on the left side, then write down here which is the mineral, and then you start what is the form, how it looks this. Then you put with the color. It's a black color, white color, or it may be the blue color, whatever the things. Then streak, that should be generally colorless, especially for the quartz group of minerals. Okay, and diaphanity, some are translucent, some are transparent. Say for example, I showed you here, what is this? This is translucent, this is a transparent. Okay, Milky Quartz is transparent, and Smoky, this is opaque, and this is a translucent, partially transparent light, and this is 100%, right? So next property, how you are going to write for this particular minerals. This is one mineral, this is one, like this. There are three minerals in quartz group of minerals, mainly. Okay, and when you go to next, luster, how it looks, vitreous, shining is there now. Yes, of course, almost all the, these both two are shining, but this middle one, it's not shining, it's a dull luster. It looks like a dull, that's why we call it as a dull luster here. Okay, and yeah, next property is that that's called your cleavages will be present, and fracture, maybe even fracture or maybe uneven fractures, depends. Hardness, it will be medium. Sorry, it's a 7 hardness. As I told you that there are physical properties of minerals, so hardness will be the 7 for this. Okay, here you can see this, especially some of the metals like a topaz, quartz, we specified, we fix that it's a hardness for this particular mineral. The rest of the minerals are within this range it will come. Okay, depends on the silica percentage of that, right? Then next property is that next property of the quartz groups. Yes, the colorless concord of structure. Okay. Yeah, here is the properties. I would say this quartz group of minerals, and its form is maybe granular, or it may be crystalline, whatever the things. And color is varieties of color quartz we have seen there. Streak is colorless, luster is vitreous, cleavages are not there, it is called absent. And fracture is concordal to uneven. Some are showing the concordal fracture, some are showing the uneven fractures. When you break the minerals, it may break in a uneven shape. Okay, there will not be any perfect shape. So some minerals are in the quartz itself, it's showing the some concordal fracture. That's called it's just like circle, or it may be just like a vase type of the shapes are forming there. Okay, and hardness is a 7, it's a high. Or else you can you can write down the hardness. If you cannot remember in the numbering, you can write down the high, low, and medium types. Okay, and specific gravity will be low to medium, and the chemical composition SiO2. Okay, occurrence widely distributed all over India, especially you can see in the beach sands and river sands, and even almost all the rocks. Okay, and where we are using this quartz group of minerals, quartz manufacturing glasses and porcelains, and flux is a flux in the metallurgical operations. And some rock, the quartz group of minerals, agate is also there, agate, amethyst. These minerals, agate, generally we use it for ornamental stones, and amethyst are considered as a semi-precious stones, like diamond is a precious stone, right? uh, like that, this agate, amethyst, these are all the ornamental stones, and semi-precious stones we use it for that. Okay, pure quartz crystals shows piezoelectricity property. That's why we use this pure quartz crystals in ultrasonic what you call equipment. So quartz plates are used in controlling the frequencies in radio circuits, radar, ultrasonic, and multiple telephone lines. Keep in mind this. Say quartz plates are generally used controlling the radio frequencies, radar, ultrasonic, and multiple telephone lines. That's how things. And also used its fiber quartz wires frequently used for transmission of telephone messages. Okay, and this is how it is, and it is also used for especially in the refractory bricks, high heat resistance, the bricks and products where they are manufacturing with this quartz, because of it's a high, hardness is high. So above the 6, the hardness is always high. So pure silica is used in ceramic products, manufacturing ceramic and sanitary products. So pure sand, free from the impurities, used for manufacturing sand and abrasive cloths. So if you see this list of uses of what you call this quartz, there is a huge, and some are like very sophisticated what you call to say this radio circuits, radar, ultrasonic, multiple telephone lines, and even in refractories. Okay, those things you can see this how the very important of this quartz. Okay, and varieties of quartz you have seen this. And before going for the feldspar group of minerals, okay, so here before I go back to that, so here I would say it is in a we reach up to the this level. Yeah, so this is actually uh, uh, entire the mineral group. We have divided into three. One is silicate minerals, another one is non-silicate minerals, third one is non-silicate with the ore minerals. So in the silicate group of minerals, quartz group, feldspar, mica, amphibole, garnet groups. And here another is called carbonate group of minerals, that's calcite, dolomite, and magnesite. And here in a non-silicate ore forming minerals, you can see galena, pyrite, chalcopyrite. Yeah, you can see the green one. Okay, oxide group of minerals, that's actually hematite, magnetite, bauxite, and corundum. Okay, and sulfate group, it's a gypsum and barite. So these properties are very the clear cut. The quartz group of minerals generally we use it for that we discussed just now, and feldspar group of minerals we use it for ceramic products, manufacturing of ceramic products. Mica group of minerals generally we use it for electrical industries. Okay, and amphibole group of minerals is a semi-precious stones. Garnet is also semi-precious stones for that, and carbonate group of minerals like a calcite, dolomite, magnesite. These three generally we use it for manufacturing of cement, manufacturing of cements. Okay, and sulfite, galena is a lead, manufacturing of lead, ore of lead, and pyrite is just sulfuric acid, manufacturing of sulfuric acid. Chalcopyrite we use, it's a ore of called copper manufacturing, copper. Okay, and oxide group of minerals. In oxide group, there is hematite and magnetite, and these two are mainly raw material for manufacturing of iron and steels. Okay, and bauxite is an alumina. Okay, manufacturing of aluminum. Okay, this is all oxide group of minerals. And sulfate, Gypsum again, we use this one for manufacturing of cement industries because it's having the bonding nature, so it will stick on that. So these are all the main what you call this classifications for minerals: silicate, non-silicate, rock forming minerals, non-silicate minerals, ore forming minerals. These are all rock forming, these are all ore forming minerals. Okay, and many uses. So now, before going to the feldspar group of minerals, let's go back to the picture. Yeah. Yeah, this is how the quartz we can see in the field itself. It's actually the field photograph, not from the internet photographs. Okay, it's a field photographs, and where I did for research, especially in the for gold explorations, and it's how the gold mineralization happened, and generally it is in the shear zones where the shear zones are there, where there is of the vein type of quartz, which are completely controlled with the what you call the folds, faults, joints, geological structures. Okay, those areas you can see the quartz, and also this in what you call the groundwater occurrence. Most of the groundwater occurrence generally you can get it the source from the quartz vein. It is actually it's a very what you call, where there is a fractured zones are there in the granite. Say for example, granite is a very solid rock. Okay, there is no fracture. Okay, it's very difficult to get the fracture and the cracks there. And even if it is happening there, and there will be quartz vein, thin quartz vein. Okay, and because due to this low strength, and there is movement of groundwater in the subsurface, where you will get when you are going to drill the borehole for water, and where you will get what you call this quartz vein, thin quartz vein. Definitely there is a chances of getting the groundwater. Definitely. Okay, that's how you can see the field photographs here. And apart from that, you can see the associated with that there is a iron ore the manufacturing of, which is a raw material for iron and steels. Okay, this is a quartz associated with the BIF, I mean banded iron formations. Okay, this is it's one of the best field photographs. I would say it's just looks like sandwich, which you can see this here. This is completely okay, and here is the top is the iron ore, and bottom is also iron ore here, and in between there will be lot of stuffs called quartz is there, and some clay materials stick with the quartz grains, and yeah, this is completely looks like the sandwich. Okay, right, this you can easily remember this how it looks like. And we call it as in metabasalts, basalt. In that there is a metabasalt, partially metamorphosed. The basalt is partially metamorphosed, partially converted, partially altered to some other rock. That's called a metabasalt. So here, the what you call this thin vein of quartz is not exactly visible, but there are some yellow, the grains are there. That's called pyrite. Pyrite is nothing but it's just like the foolish gold. When you see someone, the normal common people, yeah, it looks like a gold. He may not say it looks like a gold. It's exactly gold. That's called it will make the people foolish. So that's a foolish gold. So this is how the quartz vein, the pyrites are visible here. And here you can see like this in granite, you can see the quartz vein in the subsurface of the earth. Down below you can see like this, and when you are going to drill it, if you encountered this zone is, we call it a weaker zone, and also it is host of many valuable minerals. Okay, in gold formation, gold mineralization also, it plays a very major role. Where there is a quartz vein is there is a gold the deposit will be there. Mineralization is happening there. Okay, so in Hatti gold mines, Raichur districts, this is the same scenario, quartz vein. And in KGF, Kolar Goldfield also, you might have, seen, you may not seen exactly in the picture in the KGF movie, but you may, assumption that you can do that. This type of vein may be running down below the earth, and, which accumulates what we call this gold. Okay. Yes. Yeah. And I'm not going for that. Let me show some more the photographs. Where you will get those things, and it's easy for you. Here is some more. Best photographs. No, this is not a good one. Yeah. Here you can see this. It is not in the subsurface. It is on the surface of the earth. I would say this. This is. You can see the quartz veins, how they are running in the other rocks, right? This is complete the meta basalt. Basalt, I would say, you can call it as a basalt rock, and in that there will be the quartz veins are running, thin veins, and there is thick veins are running here. These are all indicates there will be chances of getting the gold mineralizations. Okay, right. See, you can see this. This is a gold mineralization. I mean the thin vein of gold mineralizations. It's this, and there are some folds are also here. You can see this folds. Okay, and yeah, see here series of the quartz veins that you can see this. Yeah, when you drill for sampling purpose, take out the core, and it's the impression of when you blast it, and you can see this type of the imprints in that. See here, you can see this. This is the somebody has drilled for this for the sample collection, and they take out the core, and it's left behind like this. Okay, this is running the meta basalts, and these are the windmills, and next to that there will be a called Gadag. Maybe you might have heard this, the Gadag district here. Next to that there will be Gadag down below this. Yeah, this is how in the field you can see the quartz vein in that along with that. Where wherever you see like this, maybe a granite associated to the quartz vein, maybe a basalt associated to the quartz vein. These are all indicates very good gold mineralization or any mineralizations. Okay, that is a possibility of comfortable zone to do the mineralization there. Yeah, these are all the iron ores and the districts. Yeah, I think here I've seen this. It's in one of the this is a quartz, and this is an iron ore, and this is looks like the grape bunch of grapes. Okay, and this bunch of grapes, we call it as a botryoidal habit. What you call it, a botryoidal habit. It's grapes, grains. See, look this. Okay. And here you can look this. Okay, yeah, this is completely of this like a sandwich, which you have seen, and this is called about, again there is an iron ore, and here it's called we call it as in the cracks. Okay, you cannot see any of the four faults here, so there is a continuation between all these things. So here you can see this. There you can see the fault zone here, synclinal fault. Yeah, here you can see this folds, or how this looks like, this folds. In the field itself, you can look the folds, how it is, behaving in the iron ore. This is a completely iron ore. It's in Gadag districts, nearby Gadag. There will be hardly, it's a 5 kilometer from Gadag towards Haveri district. Okay, called Nagavi area. It's in the, near to the what you call Gadag government hospital, nearby that. You can see this. These are all called metabasalts with the iron ore. Okay, a little bit the mining activities also be carried out. Some of the people there. Okay, right. Yeah. And if you go back to some other minerals, yeah, that's what we have seen there. And yeah, I need to go back there. Might have seen this place if you are nearby to the Gadag. This is old workings. This is completely, we call it as an iron ore, and here is the this old working adit. Okay, the shop they made it entering into the underground mines there for exploration point of view, and other for the mining point of view here. So it's not a recent one. It is a British time. It's a British time. They gone for this what you call this gold mining. Okay, this is one. We got very good results in this area particularly, and but it's not completely I would say it's a mineable resource. It is occurrences there, but if you go back to do some more exploration, definitely we may get very good results, and we have to check for that further explorations. It's a gold exploration found there, because they did the trenching here for soil sample. Okay, and they did for some the what you call this pits, trial pits. It's not visible properly because of thick bush. And here you can see this, the pit they did in the olden days. Okay, very olden days. These are some shear zones. You can see this type of structures in the field, quartz vein with the sheared one. That's all what you call this indicates the mineralization part in any way. Okay. Okay. Right. Yeah. Here, what we have seen there. This is the top of the the hillock. On top of the hill, what you have seen the the entire the quartz vein here. This is end of the special, and here is Gadag next to that Gadag. Video is not. It's a lot of windy there, so it's. And down below the hill, there is a lot of windmills are there in Gadag, nearby Gadag. Okay, here you can see these things, right? This is how you can see the gold field there. I mean, how the quartz veins are very, very important for gold mineralizations. Okay. Rather than, I would like to show some more the gold mineralizations, especially in the how the gold. Okay, must be okay. Here. Yeah. So here you can see some of the very good photos. Yeah. So the gold veins, what they're hosting, it's a very good gold deposits here. Okay, this is how it looks like in the field in the quartz vein, and here you can see this. This is a phyllite. It's a metamorphic rock, and here is quartz veins are running series of quartz veins. Here one, and there is next or 2 to 4 or 2 to 3 quartz veins are running here. Yeah, here you can see this, series of quartz veins. 1, 2, 3, 4, 5. So all these veins are contain some, very valuable, very good gold deposits, and I would say it's a yeah. What I would suggest here, yeah, this is how the gold working here, right? This is the typical properties of quartz, varieties of quartz, and uses, and how they are useful for the industries. Okay. The next part is that this is a feldspar group of minerals. As I show in the last class, the feldspar group of minerals. Okay. Feldspar group of minerals. Yeah, these three are feldspar group of minerals: orthoclase, macrocline, and plagioclase. And these three generally we use it for manufacturing of ceramic products. Okay, and yeah, yes, feldspar group: orthoclase, plagioclase, and macrocline. Okay, and if you see the the minerals, it looks like almost same properties, and there are some the chemical composition changes here, and also what you call this. There are some vitreous luster, and also yes, and generally most all three minerals orthoclase. It's a color. It's a white, pink, and green color. These three minerals are here. You can see this. Okay, and the description you can say it here. Properties: color is varieties of color. Form is it's a tabular form. Some are massive or tabular form. See here, tabular is in the sense it's sheet-like structures. Here you can see this. Okay, and streak is colorless. Okay, and the luster is vitreous. So all three are shining.
Excuse me, sir.
Hello. Yes.
Sir, we are not able to hear your voice, it seems, sir.
Is it?
Yeah,
Oh,
sir. More
since
than 2 or 3 members have been messaged me.
messaging, don't message. I'm not seeing the message here.
No, sir, they're texting me. I'm able to hear, but they are not able to hear, it seems.
Or maybe a phone problem. They have a phone problem. Okay. So here, these three are feldspar group of minerals. Okay, right. So for these minerals, these are the properties. Okay, pink, white, and green color, orthoclase, plagioclase, and microclase. So here, these three are orthoclase, plagioclase, and microcline minerals. Okay, and the properties are like this: table-like form, looks like a table, sheet-like structures. Streak is colorless, and luster is vitreous. and cleavages are present here. Now we are going to identify the cleavages are here. It's very difficult to show, but I can try to show the things here. The hands-on specimens, you can see it easily, and where you can see the weaker zones here. When you break these minerals, definitely it will break along this zone, weaker zone. Okay, that's called a cleavages. Okay, and so hardness is 6. Okay, it's a little bit the quartz, rich of quartz is 7, and remaining this feldspar group, orthoclase, plesioclase, and microcline, all are 6. Medium hardness, and specific gravity, it's a medium, not too heavy, not too low, not high heavy. So it's a medium specific gravity. And chemical composition, what is there in these three E? Okay, in these three, here you can see the potash feldspar and soda feldspar and potash feldspars. And we cannot prove it all this, the especially the chemical composition, because we are not going to do the any titration work, or maybe we are not going to test using the XRF machine. Okay, it is already determined that these are the chemical compositions of there. And here, what you call this, these properties, it may be changed. Pink, the color may be changed, form may be changed, streak may be changed, luster may be changed, cleavages or may be changed. From place to place, these mineral properties may be changed. If these minerals are available, occurs in Karnataka, it may be a little bit different properties. And it may not be the 100% change. It may be a little bit, 40 to 50% variation will be there in the physical properties. Okay. If you see the same mineral, name will be the same, but the properties will be different in a different countries, because based on the the nature, based on the the chemical composition, based on the environment where it was deposited. So it has changed everything here. Okay, right. Then here the occurrence, it occurs in almost all the igneous rocks, especially in the granite. You can see granite rock and pegmatite rocks. Okay, these minerals are you can see in the granite and pegmatite. Okay, not in sediment rocks, in igneous rocks. Okay, so where we are using this, we are using the manufacturing of sanitary products and earthwares. Okay, and also we use this porcelain bits and tiles, manufacturing of tiles. This is a raw material for manufacturing of the sanitary wares and also for the tiles manufacturing. Okay, right. So the mica group of minerals we'll discuss in the next class. So there are, okay, let's finish this this one actually. So here yesterday we have seen this, the mica group of minerals. Yeah, here you can see this. It's a very thin sheet, looks like a very thin sheet, but high heat resistance. It is having the high heat resistance. Okay, and here you can see this, the biotite mica and muscovite mica. Biotite mica, it's completely black color. Okay, so this is let me put into this feldspar. Yeah, that would be the better. Yeah, it's visible. I think it's not visible, this one. Okay, so here in the biotite mica and muscovite mica, biotite mica is the black color and muscovite mica is the white color. Okay, so here how to identify these properties? The color will be the black, you have seen there, and the form will be the foliated. It's just like a sheet, foliated form, and the streak will be the colorless, or it may be the white. Okay, so here is a diaphanity, translucent. No, it may not be transfer the light 100%. Partially, it may be transferring because it's very when you take it, it's a very thin section. It's just like your paper, thin paper. That much of the thickness will be there. Okay, and the luster, it's a purely luster. It's just like a greasy feeling. And cleavages are present. So when you break this metal, it will break in a perfect, the sheet-like structures. Okay, and fracture is uneven fractures. Means where there is a cleavages are present, the fracture will be the even. That means it will cut the it will be the mineral will break in a proper manner. Okay, the hardness. What is a hardness? It's a medium, not a medium. It is a low hardness, very low. You can break it easily with your hands. Okay, and specific gravity, it's a low specific gravity. Okay, and the chemical composition, some more maybe the heavy looks like this specific gravity. Depends on the thickness. When you make it small one, it may be very lightweight. And chemical composition is it will be having the magnesium, iron, alumina, potassium. Okay, it is a silicate of alumina and potassium. This is a muscovite mica. This is white one. Biotite mica is the black one. Okay, and occurrence, it occurs in igneous metamorphic rocks. Both are same. Occurs in igneous rock, and generally it is used in insulating the electrical apparatus. Okay, right, electrical industries. So this is all about today's class. Quartz group of minerals, mica group of minerals, and also the feldspar group of minerals. Okay, quartz group of minerals, generally we use it for manufacturing of the glasses, and the feldspar group of minerals used for manufacturing of tiles and ceramic products, and this mica group of minerals used for the electrical industries. Okay, and yeah, so let's take this right.